Hi, and welcome to the Smart Nursing Home demo. Smart Nursing Home collects and analyzes patient data, like the body temperature and the pulse rate, notifying nurses during the night in case of anomalies like patient in a fibrillation state or with a low pulse rate. Allows to monitor the rooms of a nursing home, setting the temperature and the luminosity of the patients and common rooms. This is the structure of our platform. Nurses and doctors can interact through Telegram. In particular, nurses will receive alerts and doctors can manage patients. Doctor can see patients' data statistics through the ThinkSpeak dashboard. Terminal allows to add at runtime new users or rooms in the system. Raspberry Emulator is the device connector, sends patients and room data to the microservices and receives actuation command. In our implementation, since we emulate data, this will generate data for all the patients and rooms we had. Now I will run the system using a HMake file to build the images, and through the Docker Compose we'll run them. Let's have a short look in the catalog. As we can see, we have already a user for Telegram. We have already a patient room and a common room with the desired temperature. Let's start opening now Telegram bot. There are three possible users. Nurses, doctors, and super users that can do the operation of both. Now I'm a super user, so I can manage patients and receive notification. I will log in and start works. That means that the user has started his work shift, so he can receive notification. When the user will end his work shift, he can click on the end work to not receive notifications. As already said, the doctor can add a patient, inserting the data, or can do a lot of several operations like search for it. Now I will add a patient and then I will search this patient by his ID. To see the behavior and the output of the microservices, I will run a script that will send specific data to the microservices in order to emulate a particular condition. I can emulate in 9 cases for rooms and for patients. Starting pressing 1, I can emulate a temperature of 27 degrees during summer in a patient room without the presence of the patients. Let's now open the container's terminal and see the actuation command sends. The container sends to the Raspberry an actuation command indicating to put the air conditioning on, because the system expects to find the users in the room at that time, and the current hour is 8, and the desired temperature is of 23. So the system tried to keep the temperature at 25 degrees. Now here is the flowchart of the microservices. Now I will pressing 2. I will emulate a temperature of 24 degrees for the common room during summer without the patients. The container will send to the Raspberry an actuation command indicating to put the air conditioning off, because even if the desired temperature is lower of the current temperature, there are no patients in the room, so the system will keep the temperature higher than 24. Pressing 3, I will simulate a case when the patient has the light on. So let's see the actuation command sent by the light monitor microservices. This will notify the Raspberry to set the luminosity of at the percentage of 15. This value is computed taking in consideration the current weather condition of the setting of the nursing home, in our case Turin. The microservices will receive that data, and since it's day and we have higher visibility without cloud cover, the luminosity is set at the lower value. I can see the data received by the microservices through Postman. Now, pressing 4, I will start emulate data for a patient with the ID 1. First, I emulate a sensor with a low battery level in order to receive the alert on Telegram. Let's first check the output of the container. In particular, the alert is sent since the current battery level is under a certain threshold set by us. Opening Telegram, I can see the notification. Now, pressing 5, I will emulate a body temperature for the patient 1 of 39 degrees. Since this value is higher of a threshold set by us, the nurse will receive a notification on Telegram. Let's first check the output of the container and then check the notification on Telegram. Here is the publish of the message. Here is the notification. Pressing 6, I can start emulate saturation and pulse rate for the patient 1. I will send the last 10 samples collected from the sensors. I will emulate a fibrillation state. Fibrillation is computed considering the standard deviation of the good measures collected, and since in our case the standard deviation is higher of a threshold of 5, the nurse will receive a notification of fibrillation. Pressing 7, I can emulate a bed position sensor since the perfusion index values are under a certain attendability thresholds. That means that the measures are not correctly taken. Pressing 8, I can emulate a low pulse rate for the patient 1. It means that the mean of the heartbeat samples is under a certain threshold. The message indicates also the value of the heartbeat. To conclude, I emulate a case of hypoxia. The microservices detect it, analyzing the values of the saturation vector, and in the alarm sends also the percentage of blood saturation. Until now, I used the data prepared appositely to generate events. Now I will open the terminal of the container of the microservices Raspberry emulator, microservice that allows to generate data for the patients and rooms every n seconds, registering and updating services and devices. In the real case corresponds to attach sensor to the patient and to the Raspberry and start collecting data. I will now add the patient 1 in the room 1. In the real life means to plug the sensor to electricity, generating data for that patient. From now, Raspberry emulator will start emulate data for the room and the patient 1, together with data emulated for the common room 3 that I've added. It will also receive actuation command. From Postman, as you can see, I have added, I can see the devices registered by the gateway. I can remove a patent, it means to unplug the sensor, and if it happens accidentally, the patient device analyzer will detect the patients that are without sensor attached, sending notification to Telegram. Since this check happens periodically and not instantaneously, in the meanwhile to receive the notification, I will open the command line of the terminal microservices. This allows to add at runtime or remove or edit users or rooms in the catalog. The persistence of the data is guaranteed thanks to the Docker volume that is defined in the Docker compose. In the meanwhile, the Raspberry emulator is sending patient and rooms data and receiving actuation command. Since it is passed some times now, opening the terminal of the patient analyzer, I can see that the microservices detect the absence of the two sensors and sends the two Telegram notification. To conclude, I will open the ThinkSpeak dashboard as a doctor, so I can see the data for each patient of the nursing home. In particular, in this case, for patient 1, I can see data collected over the time, and for each type of data, even the average.